All right, let's talk about algebra. I know, for a lot of us, that word alone is enough to make you shudder a little, right? But what if I told you it's not nearly as scary as we remember? Stick with me because in the next few minutes, we're going to demystify this thing together. I mean, you've probably wondered this, right? You're going along just fine in math class, everything makes sense, and then bam, suddenly, letters just crash the party. It feels like the rules of the game just completely changed overnight. Well, today, we're going to figure out exactly why they're there and, more importantly, what they actually mean.
And for so many of us, this is where we hit what I like to call the great algebra wall. You know that feeling? It's the exact moment math stops feeling like simple counting and starts feeling, well, weird, abstract, confusing. If you've ever felt that way, trust me, you are not alone. And today, we're going to start knocking down that wall brick by brick.
So here's the real heart of the problem. Arithmetic, right? That's all about concrete numbers. You can picture two apples plus two apples. But algebra brings in these abstract symbols that are supposed to be numbers. And that leap from something real to something abstract is why it feels so shaky at first. It's almost like you're trying to build a house, but the foundation suddenly turns to sand. And this leads to some really common hurdles. I bet you'll recognize some of these. First, you've got the whole mystery of the unknowns, the x, y, and z. Then maybe those basic arithmetic skills are a little shaky, and they come back to haunt you. Oh, and the classic trap, memorizing a bunch of rules without ever understanding why they work. Throw in some super long multi-step problems and that constant fear that one tiny mistake will mess up the whole thing. Yeah, it's no wonder it can feel so overwhelming. All right, so let's get into it. Let's start cracking this code. First things first, we have to tackle the most infamous letter in all of math history, x. But I promise you, it is nowhere near as scary as it looks. So what is a variable? It's just a placeholder. That's it. Seriously. The secret is to stop thinking of x as a letter and start thinking of it like an empty box or a blank space in a puzzle. It's just a temporary spot for a number that we don't know yet. Okay, get ready, because this is the big aha moment. On the left, you've got a problem from like second grade. 5 plus blank equals 8. Simple enough. Now look at the right. An algebra problem. 5 plus x equals 8. Do you see it? They are asking the exact same question. All algebra did was swap out the blank line for the letter x. It's not a new kind of math. It's just a language update. Okay, so now we know x is just a placeholder for a missing number. But how do we actually find that number? Well, it turns out there's one simple core idea, a kind of golden rule that unlocks pretty much everything in algebra. I want you to picture this in your head. An equation is like one of those old school balance scales. You know, the two pans? The equal sign is the pivot point right in the middle. And for that scale to stay perfectly level, the stuff on the left side has to weigh the exact same as the stuff on the right side. It has to be in perfect balance. And that simple idea leads us straight to the golden rule. And it's this. Whatever you do to one side of an equation, you must do the exact same thing to the other side. You want to add 5 to the left side? Go for it. Just make sure you also add 5 to the right side. That's the only way to keep that scale perfectly balanced. Okay, let's put this rule into action. Here we have x plus 7 equals 15. The goal is simple. Get x all by itself. So what's messing that up? That plus 7. To get rid of it, we do the opposite. We subtract 7. But remember the golden rule. To keep things balanced, if we subtract 7 from the left, we have to subtract 7 from the right too. So on the left, plus 7 and minus 7 cancel each other out. All that's left is x. And on the right, 15 minus 7 is 8. And boom, just like that, we've got our answer. X equals 8. All right, so we've got the what and the how. But that brings us to the biggest, most famous question in math history. When am I ever going to use this in real life? Well, the answer is going to surprise you. Because the truth is, you're already using it. Probably every single day, and you don't even realize it. No, really, think about it. Ever had to double a recipe or figure out if you have enough gas to make it to your destination? What about managing a budget or even just calculating a discount at a store? Every single one of those things is algebraic thinking. You're constantly solving for some kind of unknown in your day-to-day life. Let's take a super practical example, the kitchen. Let's say your favorite cookie recipe makes enough for 4 people, but you've got 12 people coming over. You've got to scale everything up. So, what's your first move?
Well, your brain instantly knows that 12 is 3 times bigger than 4. So you have to triple the recipe, right? So if the original called for 2 cups of sugar, you just multiply that by 3, and you need 6 cups. That little mental step you just did, finding that scaling factor of 3 and applying it to your ingredients, that is algebra in action. Okay, here's another one. You're about to go on a road trip. You know it's about 180 miles away, and you figure you'll probably average about 60 miles an hour. So the big question is, how long is this trip actually going to take? You might not write it down, but your brain uses a simple formula. Time equals distance divided by speed. It's an algebraic equation. You just plug in the two things you know. The distance is 180 miles, the speed is 60 miles per hour, to solve for the one thing you don't know, which is the time. 180 divided by 60, that's 3 hours. It's totally practical, and it's all powered by algebra.
So, feeling a little better about this whole algebra thing? Good. So how do we build on that? Let's wrap up by putting together a little success toolkit. Just a few key strategies to help you tackle this stuff with way more confidence. Okay, here are the keys. First, you've got to make sure your foundation is solid. That means your basic arithmetic and the order of operations, PEMDAS. Next, get good at translating word problems into actual equations. And, this is a big one, don't just memorize the rules. Really try to understand why they work. And finally, just practice. And when you make mistakes, and you will, don't see them as failures. They're just learning opportunities. That mindset shift is huge. Because when you really boil it all down, you see that algebra isn't just some random subject you have to survive in school. It's a powerful tool for thinking. It's a way to take a messy problem that has a piece missing and break it down into logical steps until you find the answer. And that's really the big idea I want to leave you with. What if learning algebra was never really about finding X? What if the whole point was to train your brain how to solve any problem? To teach you how to face the unknown, not with fear, but with a logical plan.